This video is brought to you by mywayteaching.com.
So now let us study uniform circular motion. Okay, when an object follows a circular path at a constant speed, the motion of the object is called uniform circular motion. Okay, when an object follows a circular path with constant speed, that is nothing but uniform circular motion. So the word uniform refers to speed, which is uniform, which means constant. Suppose an object is moving with uniform speed v in a circle of radius r, as you can see in this figure. Okay, the object is moving in a circular path of radius r with a constant velocity v. Okay, in this case, the velocity of the object is changing continuously in direction. The object undergoes acceleration. Okay, so here the velocity is changing continuously, which means the time interval delta t it decreases from first figure to third figure. So in the first figure it is more compared to second. In the third figure the time interval is 0. So the acceleration is directed at each point of the path towards the center of the circle. Okay, the acceleration is pointing towards the center of the circle as we are decreasing delta t. So let us find the magnitude and direction of this acceleration. Okay, so in order to find the magnitude as well as the direction of the acceleration, you just consider some of the things. Let r and r dash be the position vectors and v and v dash be the velocities of the object when it is at point p and p dash, as you can see in this first as well as second figure. Okay, r and r dash and v and v dash. Okay, by definition, the velocity at a point is along the tangent at that point in the direction of motion. So we already know this. The velocity is nothing but the tangent to that. Yeah, the velocity at that point in the direction of motion is nothing but a tangent. A tangent at that point. So the velocity vectors v and v dash, okay, it's already shown in the first and second figure, isn't it? So delta v is obtained by using triangle law of vector addition. Since the path is circular, v is perpendicular to r. So you can see in this v is perpendicular to r, isn't it? Since the path is circular, so v dash is also perpendicular to r dash. Therefore, we can say delta v is perpendicular to delta r. So, since the average acceleration is along delta v, the average acceleration, so this is also along delta v, the average acceleration is again perpendicular to delta r. Okay, if we place delta v on the line that bisects the angle between r and r dash, okay, we see that it is directed towards the center of the circle. So in the second figure, in this figure, we can observe that the same quantities for smaller time interval, delta V, and hence A bar is again directed towards the center. So in the third figure, as delta t tends to 0, the average acceleration becomes instantaneous acceleration. Isn't it? So we already studied about this. It is also directed towards the center. Thus we find that the acceleration of an object is in uniform circular motion is always directed towards the center of the earth. So now let us find the magnitude. The magnitude is given by limit as delta t tends to 0, the magnitude of delta V by t. So let the angle between the position vectors r and r dash be theta. So since the velocity vectors v and v dash are always perpendicular to the position vectors, the angle between them is also delta theta. So we can consider a triangle that is CPP dash. Okay, you can consider the triangle. Okay, that is formed by the position vectors and the triangle GHI. So the triangle CPP dash and one more triangle, that is triangle GHI. Okay, that is formed by the velocity vectors v dash and delta V. So the ratio of base length to side length for one of the triangles is equal to that of the other triangle. So we can write it as so the ratio of base length to side length of one of the triangle is equal to that of the, yes, it is equal to that of the other triangle. So we can write it as delta V by V is equal to delta R by R. So in other words, we can write it as delta V is equal to V delta R by R. So therefore, the magnitude is given by limit as delta t tends to 0, it is delta V by t, isn't it? Delta V by delta t. And we got the value of delta V. So you can represent it like this. That is V by R you can take outside, limit delta t tends to 0, that is nothing but delta R by delta t. If delta t is small, delta theta will also be small. So and r pp dash can be approximately taken to be delta r. So that delta r will be v into delta t, isn't it? So we can write the centripetal acceleration as v by r into v, that is v square by r. Thus the acceleration of an object moving with speed v in a circle of radius r has a magnitude v square by r and it is always directed towards the center. This is why this acceleration is called as centripetal acceleration. Okay. Since v and r are constant, the magnitude of the centripetal acceleration is always constant. However, the direction changes, pointing always towards the center. Therefore, a centripetal acceleration is not a constant vector. So we have another way of describing the velocity and the acceleration of an object. Okay, another way of describing velocity as well as acceleration of an object. So in uniform circular motion, as the object moves from P to P dash in time delta t, okay, the line CP turns through an angle delta t, as you can see in this figure again. Okay, the line CP turns through an angle delta t, isn't it? See, the line CP turns through an angle delta t. So we define the angular speed W as the time rate of change of angular displacement. Okay, we can write the angular velocity as time rate of change of displacement, angular displacement. So if the distance traveled is considered as delta s, then we can write it as, so then we can write the velocity v as delta s by delta t. Okay, but we also know delta s is nothing but r into delta theta. So and delta theta by delta t is nothing but w. So delta s is nothing but r into w. We can represent the centripetal acceleration AC as v square by r, isn't it? So we can represent it using w square r square by r. So that is w square into r. So the time taken by an object to make one revolution is known as its time period t, and the number of revolution made in 1 second is called its frequency. So v is equal to 1 by t is frequency. However, during this time, the distance moved by the object is s is equal to 2 pi r. So we can write v is equal to 2 pi r by t, that we can write it as 2 pi r v. In terms of frequency v, we have w is equal to 2 pi v. So if you want to write it in terms of frequency, then we have w is equal to 2 pi v, and that is v is equal to 2 pi rv, and the centripetal acceleration we can write it as 4 pi square v square into r. So let us consider a simple problem on this. The problem is, an insect trapped in a circular groove of radius 12 centimeter moves along the groove steadily and completes 7 revolutions in 100 seconds. What is the angular speed? The linear speed of the motion. Is the acceleration vector a constant vector? What is this magnitude? So this is an example of uniform circular motion, and here they have given the value of r as 12 centimeter. So the angular speed, the first question they have asked to find angular speed, that is 2 by t. Okay, they have given the value of time period as 100 seconds. So the angular speed is nothing but 0.44 radian per second. So the linear speed is given by W into R. So we know the angular speed 0.44 and the linear speed is 12 centimeter. So the value of R is 12 centimeter and the linear speed is 5.3 centimeter per second. Okay, the direction of velocity v is along the tangent to the circle at every point. The acceleration is directed towards the center of the circle. Since this direction changes continuously, acceleration is not a constant factor or it is not a constant vector. However, the magnitude of the acceleration is constant. So we can find the magnitude of the acceleration, that is A is given by W square into R. So the value of W is 0.44, so whole square, and the value of R is 12 centimeter. The centripetal acceleration is given by, or the acceleration is given by 2 pi centimeter per second square. This is all about the uniform circular motion.